Welcome to Maths class, Matrices part 4. So in the last class, we have been discussing the multiplication of matrices and the condition for multiplication of matrices. Matrices A and B are conformable for multiplication in that order AB if the number of columns of A is equal to the number of rows of B. So this is the condition for multiplication. మాత్రికల గుణకారానికి ఇది నియమం. మొదటి మాత్రికలోని నిలువు వరుసల సంఖ్య రెండవ మాత్రికలోని అడ్డు వరుసల సంఖ్యకు సమానం అయినప్పుడు రెండు మాత్రికలు గుణకారం చేయవచ్చు. So this is the basic condition for multiplication of any two matrices. And this is the definition. Product of two matrices. Rendu matrikala labdam. Suppose if A is a matrix of order m by n, B is a matrix of order n by p. A అనేది m by n అంటే m అడ్డు వరుసలు n నిలువు వరుసలు ఉండే మాత్రిక. B అనేది n by p అంటే n అడ్డు వరుసలు p నిలువు వరుసలు ఉండే మాత్రిక అయితే if A is a matrix in which m rows and n columns and B is a matrix in which n rows and p columns, here clearly the condition is satisfied, then you can multiply A with B, AB exists, and the multiplication, the product matrix AB, that is equal to C, let us name it the product matrix of AB as C, and that will be order of m by p. In the product matrix, the rows, number of rows will be m and the number of columns will be p. ఈ ఏబీల గుణకారము లబ్ధ మాత్రికను గుణకార లబ్ధ మాత్రికను సి అనుకుంటే ఈ గుణకార లబ్ధ మాత్రికలో m అడ్డు వరుసలు p నిలువు వరుసలు ఉంటాయి. సో దిస్ ఇస్ ద డెఫినేషన్ ఆఫ్ ప్రోడక్ట్ ఆఫ్ టూ matrices. And what is C here? C is the summation of aik bkj. So we did some problems in the last class. Now in continuation, let us practice some more problems. So look at this. In exercise 3b, Roman 1, second problem. If A is a matrix 1, 4, 1, minus 2, 3, minus 4, 2, 5, and B 2, 3, 4, 5, 2, 1, do AB and BA exist? If they exist, find them. Do A and B commute with respect to multiplication? ఈ విధంగా ఏబీలు రెండు మాత్రికలు అయితే ఏబిబిఏ వ్యవస్థితం అవుతాయా? వ్యవస్థితం అయితే వాటిని కనుక్కోండి. ఏబీలు వినిమయం అవుతాయా అన్నది ఇక్కడ సమస్య. నౌ ఫస్ట్ లెట్ us see AB, whether AB is possible or not. Now let us take A, 1 minus 2, 3, minus 4, 2, 5. So this is A. order of this matrix is 2 rows and 3 columns. దీని పరిమాణం. And B 2 3 4 5 2 1. So this is second matrix. Order of this one, 3 rows are there and 2 columns. So the order of this is 3 by 2. Here columns, number of columns in first matrix, that is 3. Number of rows in second matrix are equal. So this is equal. Therefore, the condition is satisfied. We can multiply them. AB is confirmable. AB ni kanukovachu, AB ni guninchavachu. So here number of columns in A equal to number of rows in B. So number of columns in first matrix are equal to number of rows in second matrix. మొదటి మాత్రికలో అడ్డు వరుసల సంఖ్య రెండవ మాత్రికలో నిలువు వరుసల సంఖ్యకు సమానమైతే ఆ మాత్రికలను గుణించవచ్చు. సో multiplication is possible. AB exists. So here the product of AB exists. If AB exists, find AB. Now let us multiply. Multiplication is possible, and that product AB matrix exists. వ్యవస్థితం అవుతుంది. Now let us find AB. How to find AB? The method of multiplication, taking the rows in first column rows, first column rows, second column, second matrix divide into columns. So here this is first row R1, this is R2. 2 rows are there. So in second matrix 2 columns. This is first column, this is second column. Taking the row, this is the row in first column, and this is the column, first column in second matrix. This is the first row in first matrix. So now how do you multiply rows with columns? So first one, you take R1 and multiply with C1. Next, take R1, multiply with C2. And next, take R2, multiply with C1, and R2 multiply with C2. So this is the procedure of multiplication. We know, we did yes in the last class. So now look at this. 1 minus 2 3, multiply with 2 4 2. Clearly 3 elements are there in R1 and 3 elements are there in C1. So multiply the corresponding elements. First element with first element of R1 with first element of C1. That is 1 into 2. So 1 into 2. Next, place second minus 2 into 4. Minus 2 into 4. Place, here I think the place is not sufficient. 1 into 2. 1 into 2 plus minus 2 into 4 minus 2 into 4 plus third element with the third 3 into 2. So this is R1 C1. Next R1 C2. You can see 1 into 3, 1 into 3. So first number with first number of C2. Minus 2 into 5. And 3 into 1. This is R1 C2. Next R2 C1. R2 minus 4 to 5 with 2 4 2. Minus 4 into 2. Minus 4 into 2 plus 2 into 4 plus 5 into 2. R2 C2 minus 4 into 3 plus 2 into 5 plus 5 into 1. So this is the multiplication R2 C2. Second row of first matrix with the second column of second matrix. Now simplify. 1 into 2, 2. Minus 2 into 4, minus 8. 3 into 2, 6. 1 into 3, 3. Minus 2 into 5, minus 10. 3 into 1, 3. Minus 4 into 2, minus 8. 2 into 4, plus 8. 5 into 2, 10. Minus 4 into 3, minus 12. 2 into 5, 10. 5 into 1 is 5. Further simplifying, here 6, 2 plus 6, 8, 8 minus 8. So that is 0. 8 minus 8 is 0. Here 3 plus 3, 6. 6 minus 10, minus 4. Minus 8 plus 8 will get cancelled. This is 10. 10 plus 5. 15 minus 12 is 3. So this is A, B. So this is AB. 0 minus 4, 10, 3. Now, let us see whether BA. Now let us find BA. Now write B first. 2, 3, 4, 5. 2, 3, 4, 5. 2, 1. So this is B. The order is 3 by 2. And A, 1 minus 2, 3. 1 minus 2, 3. Minus 4, 2, 5. Minus 4, 2, 5. So this is A. The order is 2 by 3. Here, the number of columns in first matrix is 2. And this is equal to number of rows in second matrix. Therefore, condition is satisfied. You can multiply B with A. So BA exists. Since the number of columns in B is equal to number of rows in A. Therefore, BA exists. BA is possible. Now, let us multiply BA. Now, let us multiply BA. Now, same procedure. BA here, 3 rows are there. So this is R1, R2, R3, 3 rows and 3 columns. Here in second A, this is C1, C2 and C3. Now R1, C1. The multiplication is R1, C1, R1, C1, R1, C2, R1, C3. 3 columns are there. So multiply R1 with C1, C2, C3 and multiply R2 with C1, R2 with C2, R2 with C3. Similarly, R3, C1, R3, C2, R3, C3. So this will be the product of BA. So now let us multiply R1 with C1. 2, 3 with 1 minus 4. 2 with 1. 2 with 1. 2 into 1. So now 2 into 1 plus 3 into 4. This is R1 C1, R1 C2. 2 into minus 2 plus 3 into 2. Next, R1 C3. 2 into 3 3 into 5. Next R2C1. 4 into 1. 4 into 1 plus 5 into minus 4. Next R2C2. 4 into minus 2 plus 5 into 2. Next R2C3. 4 into 3. 5 into 5. 4 into 3. 5 into 5. R3C1. 2 into 1. 1 into minus 4. 2 into 1. 1 into minus 4. R3C2. 2 into minus 2 plus 1 into 2. So R3C3. 2 into 3 plus 1 into 5. So this is multiplication. Now you have to simplify. 2 into 1, 2, 3 into minus 4, minus 12, 2 into minus 2, minus 4, 3 into 2, 6. 2 3 ja 6, 3 5 ja 15. 4 1 ja 4, 5 into 4, 5 into minus 4, 20. 4 into minus 2, minus 8, 5 2 ja 10. 4 3 ja 12, 5 5 ja 25. 2 1 ja 2, 1 into minus 4, minus 4, 2 2 ja minus 4, 1 2 ja 2, 2 3 ja 6, 1 5 ja 5. Further simplifying, 2 minus 12 is minus 10, 6 minus 4, 2, 15 plus 6, 20, 1. 4 minus 20, minus 16, minus 8 plus 10, 2, 12 plus 25, 37, 2 minus 4, minus 2, minus 4 plus 2, minus 2, 6 plus 5, 11. So this is BA. So AB and BA both exist, but AB is not equal to BA. AB not equal to BA. Therefore, A and B are not commutative. So they are not equal. Therefore, AB are not commutative. ABలు వినిమయం కావు. Not commutative with respect to multiplication. గుణకారం దృష్ట్యా ఇవి వినిమయం కావు with respect to multiplication. of matrices. మాత్రికల గుణకారం దృష్ట్యా మాత్రికలు వినిమయ న్యాయాన్ని పాటించవు. So here we have to multiply AB and BA after checking the condition. Then we notice that they are not equal. AB and BA are not equal, therefore it is not commutative. The matrix multiplication is not commutative. This is very important conclusion. So now let us take another problem from the textbook. If A is equal to I0 0 I0 0 I is the complex number, then find A square. Okay. A square is equal to A into A. A square is nothing but A into A. So multiply A with A. That is I0 and 0 I into I0 0 I. Here the condition is satisfied. 2 by 2. The rows, columns in first matrix are equal to rows of second, number of rows in second matrix. Therefore, multiplication is possible. Then how do you multiply? First rows R1, R2 in first matrix with columns of second matrix. So rows and columns. So now it is R1 C1, R1 C1, R1 C2. Take the first row, multiply first column, R1 C1. Take the first row, multiply second column, R1 C2. Next, take the second row, multiply with first column. Take the second row, multiply with the second column. So this will be the product matrix. This is of order 2 by 2. 2 rows, 2 columns. Now multiply I0 with I0. Elements. First element with first I into I, that is I into I plus 0 into 0. This is R1 C1. I0 0 I into 0 plus 0 into I. Next R2 C1, 0 I0, 0 into I, 0 I plus I0. So R2 C2, 0 0 plus I into I. So this is A into A multiplication. So after simplifying, I into I square plus 0. So I into 0, 0 into I. So 0 into anything is 0. So 0, 0. This is 0 plus I into I square. So further simplifying, this is I square, 0, 0, I square. So this is the A square. This is A square. So since I square value is minus 1, I square value is minus 1. So replacing I square with minus 1, I square ante minus 1 గుర్తుంచుకోండి. So this becomes minus 1, 0, 0, minus 1. So this can be written, you can take the minus 1 common and this becomes 1, 0, 0, 1. So this is nothing but 1, 0, 0, 1 is I. So therefore A square is equal to minus of 1001, or you can write minus 1001 is the identity matrix. So A square is equal to minus I. So second order identity matrix. I identity matrix tasma matrika. So very simple problem. A square is A into A and multiplying, and one thing, I square value is minus 1. You remember this one. I square is minus 1. That is the complex number. Now let us take one more problem from the textbook. If A is equal to 2, 4, if A is equal to 2, 4 minus 1k, so this is a matrix, given matrix, and A square is equal to 0 matrix. A square is equal to 0. Then find the value of k. Then find the value of k. A అనేది ఒక మాత్రిక 2, 4 minus 1k అయితే A square 0 matrix అయినప్పుడు k విలువను కనుక్కోవాలి. Now let us take the given condition, that is A square is equal to 0 matrix. So what is A square? A into A is equal to 0 matrix. Now substitute the A, replace the A with the given matrix 2, 4 minus 1k, 2, 4 minus 1k into 2, 4 minus 1k. This is 0 matrix, 0, 0, 0, 0. So the O is the 0 matrix. Now multiply. So as usual, multiplication is divide the first matrix into rows and second matrix into columns. R1, R2, C1, C2. So R1 with C1, R1, C1, R1, C2, R2, C1, R2, C2. So this is the procedure of multiplication. Now let us multiply 2 4 with 2 minus 1. 2 into 2, I am writing direct. 2 into 2 4 plus 4 into minus 1 minus 4. This is R1C1. Next R1C2. 2 4 with 4k. 2 into 4 8. 4 into k 4k. Next R2C1 minus 1k with 2 minus 1. Minus 1 into 2 minus 2. K into minus 1 is minus k. R2 with C2 minus 1 4. Minus 1 into 4 minus 4. K into k square. So that is equal to 0 matrix. We know the equality of matrices. When do we say that two matrices are equal? If the corresponding elements are equal, then the matrices are equal. Corresponding elements should be equal. రెండు మాత్రికలలో అనురూప మూలకాలు సమానమైనప్పుడే ఆ మాత్రికలను సమాన మాత్రికలు అంటాం. ఒకే తరగతికి చెందిన రెండు మాత్రికలలో అనురూప మూలకాలు సమానం అయితే అప్పుడు ఆ మాత్రికలను సమానం అంటాం. Corresponding elements should be equal. This is the condition for equality of matrices. First element should be equal to first, second with second, third with third, fourth with fourth. This is the corresponding elements. So for the simplification, we can take any one of them. I am taking corresponding elements, the second row first element with second row first element. These corresponding elements anurupa mulakalu. Corresponding elements should be equal. అనురూప మూలకాలు సమానం కావాలి కాబట్టి this minus 2k minus 2k minus 2 minus k is equal to 0 కావాలి. సో minus k రైట్ సైడ్ తీసుకుపోతే అది k అవుతుంది. సో the k value, therefore the k value is minus 2. So a very simple problem, how to find the k value. So now let us take down one more problem from the textbook, that is Roman number 2. First problem, if a is equal to 300 300 030 003, then find a to the power 4. Then find a to the power 4. Now look at this. It is a diagonal matrix. Clearly it is a diagonal matrix. So if any diagonal matrix, in any diagonal matrix, if A is equal to like this, A0 0 0 B0 0 0 C, then A power n is A power n 0 0 0 B power n and 0 0 C power n. So here, by using this property where n is a natural number integer, so here by using this one, A power 4 is equal to 3 power 4, 3 power 4, 3 power 4. Therefore, 3 power 4, since 3 power 4 is equal to 3 into 3 into 3 into 3, that is 81. 3 power 4 is 81. Therefore, A power 4 is equal to 81 0 0 0 81 0 and 0 0 81. And you can take 81 common, 1 0 0 0 1 0 0 0 1. You can write it as 81i, or you can leave it 8100. So this is 81 into I, where I is identity matrix. I ante tasama matrika. So that is equal to 81i. Simple problem. Now let us take another problem, another important problem from the exercise. Roman 2 4th bit. If I is equal to 1001, if I is equal to 1001 and E is equal to 0100 and E is equal to 0100, show that ఈ రెండు మాత్రికలు అయితే షో దట్ AI plus BE, AI plus BE whole cube is equal to A cube I plus 3A square BE. A cube I plus 3A square B into E, where I is a unit matrix of order 2. So we have to show this one. First, let us find the left hand side. Now, first, let us find AI plus BE. I is equal to 1001. I and B, E is given 0100. 0100. So that is equal to A into matrix, scalar multiplication of a matrix, A into all the 4 numbers four elements inside the matrix. A into 1, A into 0, 0, A into 0, 0, A into 1, A. So this is A into I. So B into all the four elements, B into 0, 0, B into 1, B, B into 0, 0. So this is B into E. So addition of these two corresponding elements, A plus 0, A, 0 plus B is B, 0, 0 is 0, A plus 0 is A. So this is AI plus BE. AI plus BE, the matrix AB0A. So now let us find its square. AI plus BE square, that is AB 0A into AB 0A. We know the procedure of multiplication, rows with columns, R1, R2, C1, C2. Now let us multiply directly without writing. So first R1 with C1, AB with A0, A into A square, B into 0 is 0. Next R1 with C2, A into B, AB, plus B into A, BA or AB. 0 into A, 0, plus A into 0 also 0. R2 C2, 0 into B, 0, A into A square. So this is A square, AB plus AB, 2AB, this is 0, and A square. So this is AI plus BE whole square, AI plus BE whole square, just like A square, A into A. So this is AI plus BE square whole square. Now we have to find cube, AI plus BE whole cube. AI plus BE whole cube, that is AI plus BE whole square into AI plus BE. So just like, since A cube is equal to A square into A, just like this. Now AI plus BE whole square, just now we found this value is A square, 2AB and 0 A square. And AI plus BE, what is AI plus BE? AI plus BE, AB 0A. So this is AB 0A. Both way, this is from step, this one, first step, AI plus BE, value is AB 0A, and its square is A square to AB 0 A square. And divide first matrix with rows as rows and second matrix columns. R1, R2, C1, C2, and multiply. So multiply A square with A, that is A cube, plus 2AB with 0, that is 0. Now A square with R1 C2, A square with B, that is A square B, plus 2AB with A, this is 2A square B. R2 with C1, 0 into A, 0, A square into 0, 0 into B, 0, A square into A cube. So this is A cube, A square B, 2A square B, 3A square B, 0, this is A cube. So this is AI plus BE whole cube, that is the left hand side, that is the left hand side. This is the LHS. So now let us find the RHS, right hand side. Now let us take RHS, AQ by plus 3A square BE, 3A square BE, A cube, I identity matrix, I ante 1 0 0 1 plus 3A square B E. What is E? 0 1 0 0 0 1 0 0. This is given in the problem. So I ante 1 0 0 1, E ante 0 1 0 0 indulo raste. A cube into these 4 elements, A cube into 1, A cube into 0 0, A cube into 0, A cube into 1. So this is the multiplication, and multiply 3A square B with all the elements. 3A square B into 0 0, this is 3A square B into 1, 3A square B. So 0 into anything or anything into 0 will be 0. ఈ గుణకారం చేసిన తర్వాత వీటిని కలపాలి, అడిషన్. A cube plus 0, A cube, 0 plus 3A square B, 3A square B, 0 plus 0, A cube plus 0 is A cube. So this is RHS. So it is very clear. LHS and RHS are both are equal. Therefore, LHS is equal to RHS. So that is this is the proof of given statement. AI plus BE whole cube is equal to AQ by plus 3A square B E. Hence proved. So both are equal in this case. A simple problem. Now let us take one more problem from the exercise Roman number 3, the second problem. If theta minus pi is equal to pi by 2, then show that cos square theta cos theta sin theta cos theta sin theta sin square theta into cos square pi cos pi sin pi cos pi sin pi sin square pi is equal to 0. We have to prove this one important problem. So given, what is given in the problem is, if theta minus pi is equal to pi by 2, to bring pi this side, this becomes theta is equal to pi by 2 plus pi. So replace theta with pi by 2 plus pi. So now cos square theta, cos theta is equal to cos pi by 2 plus pi. So this is equal to minus sin pi. So ఇవి మీకు trigonometry transformations లో ఉంటాయి. If you don't understand, just you remember, after completing the trigonometry transformations, you will come to know how this transformation takes place. Now present, for this problem, just you remember cos 90 plus theta is minus sin theta, and sin theta is equal to sin pi by 2 plus pi. Sin 90 plus theta is equal to cos, this is cos pi. So for this problem, just you remember them as it is. So this is from trigonometric transformations. So cos pi by 2 plus pi is minus sin pi. Sin pi by 2 plus pi is cos pi. So the cos theta value is minus sin pi. Sin theta value is cos pi. So in the given problem, if you replace cos theta sin theta by this minus sin pi cos pi. Now the given LHS, I am writing left hand side. What is the left hand side? Cos square theta cos theta sin theta, and cos theta sin theta, this is sin square theta. This matrix into cos square pi and cos pi sin pi, cos pi, sin pi, sin square pi. This is the LHS. We have to prove that this is equal to zero matrix. ఇది శూన్య మాత్రిక అని చూపాలి. Now replacing cos theta in minus, cos theta is minus sin. So this becomes minus plus, minus into minus will become plus. This is minus sin pi square. So cos theta is minus sin pi, sin theta is cos pi, cos theta minus sin pi, sin theta is cos pi. So sin square theta, sin theta is sin theta cos pi. So this is cos square pi. As it is, this one as it is. I am converting the theta into pi. Theta no pi loki marchukuntam. So this no change in second matrix. Cos pi, sin pi, cos pi, sin pi, and sin square pi. So minus square is plus 1. So this is sin square pi. This is minus sin pi, cos pi, minus sin pi, cos pi. This is cos square pi, cos square pi into same. No change in second. I'm writing as it is, cos pi, sin pi. This is also cos pi, sin pi, and sin square pi. Now multiply. We have to multiply both the matrices. We know the procedure: rows into columns. So this is R1, R2. This is C1, C2. So multiplying rows by columns. R1, C2, sin square pi into cos square pi. That is sin square pi, cos square pi, plus minus sin pi cos pi into cos pi sin pi. So minus sin pi sin square, cos pi cos square. So this is minus sin square pi cos square pi. So next R1 C2 sin square pi cos pi sin pi. Sin square pi into sin pi, sin cube pi, cos pi, plus minus sin pi cos pi into sin square. This is minus sin cube pi cos pi. R2 into C1 minus sin pi cos pi into cos square pi. So this is minus sin pi cos square cos cube, x into x square x cube, just like. And cos square pi into cos pi sin pi. This is cos cube sin pi. That is sin pi and cos cube. R2 C2 minus sin pi cos pi sin pi minus sin into sin, cos into cos. So sin square, cos square. Cos square into sin square. This is also cos square sin square or sin square cos square. AB or BA both are same. You can see all becoming zeros. All the elements are becoming 0. So as these two are equal and negation, they will get cancelled and becomes 0. Therefore, this is 0, 0, 0, 0. So that is equal to null matrix. So that is equal to RHS. We have to show that this is equal to 0, hence proved. So this is also very important question in this exercise. So we have to show that this is equal to 0 if theta minus pi is equal to pi by 2. Theta pi are the angles and pi by 2 is 90 degrees. Pi by 2 is 90 degrees. So converting theta into pi, then multiplying as usual, you will get the null matrix. మామూలుగా థీటాను పైలోకి మార్చుకొని దీన్ని గుణకారం చేస్తే మనకు శూన్య మాత్రిక వస్తుంది. నెక్స్ట్ one more problem. Interesting. Give example of two square matrices A and B of the same order for which AB is equal to 0 but BA not equal to 0. Give examples of two square matrices A and B of the same order for which AB is equal to 0 but BA not equal to 0. So we have to give two examples. We have to give two square matrices such that AB is equal to 0 but BA not equal to 0. So let A is equal to A0 and A0. Let the first matrix, square matrix, as A0, A0 and the second square matrix 0, 0, A. In place of AA, you can take 1, 1, 2, 2, 3, 3 or 1, 2, 2, 3. You can take any numbers in place of A, even though it works. Now let us multiply AB. So A0, A0 into 0, 0, A. You know how to multiply? So rows with columns. So R1, R2, C1, C2. Now A 0 with 0A. A into 0, 0. 0 into A, 0. A into 0, 0. 0 into A, 0. Second R2, A into 0, 0. 0 into A, 0. A into 0, 0. 0 into A, 0. So this is 0, 0, 0, 0. Here you can observe either A and B are not zeros matrices, even though its product is 0. So therefore, AB is a 0 matrix. AB is a 0 matrix. But either of them are not zeros. A is not 0, B is not 0. But even though AB can be 0, so this is an example of it. And now let us find BA. Now let us find BA. Now write B first, 0, 0, AA. B is multiplied with A, that is A0, A0. We know the process, rows with columns. So rows multiply with column. So 0, first row with first column, 0 into A, 0 into A, 0, 0 into A, 0, 0 into 0, 0 into 0, A into A square, A into A square, A into 0, 0, A into 0, 0, 0, 0, A square, 2A square, 0. You can observe that this is not equal to 0. This is not a 0 matrix. Therefore, BA not equal to 0 matrix. But AB is equal to 0. In this case, AB, in this case, AB is equal to 0, but BA not equal to 0. So with this, I conclude today's class. So these are the solved problems in multiplication of matrices. You can go through them and practice the example solved problems in the textbook and prepare your notes so that it will be easy for you. Thank you for watching.